Hello, everyone. Thanks for the introduction and for getting me set up with the tech and everything. I'm Maggie Zernhelt, and I made this tool that I think will be useful for you. So let's look at what it is and how to use it. Down's supposed to be forward. I also can just stand at the computer.
Wait.
There we go. Thank you. All right. So before we even talk about who I am or who I think you are or what this thing is, let's talk about what the inspiration was for creating a tool at all. And the inspiration was that sometimes you have a group of files that you know contains some information you need, and you have some keywords that you know are in those files in some way, and you want to get that information from those files. And you may say, there already are some ways to achieve that goal, being the command line, using grep maybe, or just in Finder, pretty simple, can also do that. And it's true, both of those things are really good for finding certain contents in files, but they both have their own challenges. And that's where my tool, Gary, comes in, is it allows for complex searching with a simple interface. So its intention is to combine the best parts of using the command line to search with the simplicity of something like Finder. So now let's talk about who everybody is. I'm Maggie Zernhout, like I said, and I work at Jamf, first as a system extension developer on the Jamf Protect team, and now as a macOS threat researcher on the Threat Labs team. And I've been at Jamf for 5 years, so that's been my professional career of serving Mac admins, and I've learned a lot through that time. And that's why I think that this tool will be useful for you, is because I've kind of come to learn what some of the challenges are of being an advanced Mac user like you all are. As a person outside of work, I enjoy climbing, I do art sometimes, I like cooking, and I enjoy programming, which is where this tool came from. It was a personal project, not intended to reflect Jamf in particular. So it's a passion project. It doesn't have Jamf's label on it. Who do I think you are? I think you are an advanced Mac user, a Mac admin, probably. This tool is also targeted at developers who might be looking in header files often, and also threat researchers who are using YARA rules, for example, which we'll talk about in a little while. But as a Mac sysadmin, I think that you will find this tool useful for all sorts of things. Finding device compliance details, for example, looking through ESLogger output. If you're familiar with endpoint security data, you can understand process relationships and timelines that way. I think also troubleshooting user issues, like looking through sysdiagnose output, is made a lot easier with this tool. You can also understand the relationships of different files to each other more easily by using this tool, so that could help you in writing scripts. And I'm sure there are many things that you do in your specific work day-to-day that this tool could be used for that I don't know about because it's your world, but I hope that you'll come up with other ways that I haven't described that you can use it. So one of the major features of this tool is that it is a YARA editor graphical user interface. It's simple free and offline, which is a differentiator between it and other existing like YARA editors. None of them are as easy to interact with, I think, as this one. And you may be wondering at this point, what even is YARA? And it is a pattern matching Swiss knife is the way that the repo README describes it in the first place. But we'll be able to use it to identify which files contain which things. And we'll look through a lot of examples for that. As a threat researcher, I use it to differentiate malware families where certain groups of malwares contain different kinds of strings. So YARA is one of the 3 pieces that I'd like to point out of the tool at this point. The second one is a variation of grep, which is a native macOS command line tool that you probably know about already. Also does pattern matching. The big difference between it and YARA here is that it shows the matched lines, whereas YARA just shows which file matched. So my version of grep, Gary grep, is a pared down version. Grep has a lot of options, whereas Gary grep has only the most useful functionality from the huge amount of flags and options that regular grep offers. So it's a lot more simple to start to use. And then the last thing that I would like to point out of the 3 features here is that it integrates with sysdiagnose output to be able to describe individually the different files that a sysdiagnose run produces. So you can search in those descriptions, and if you're like me and you don't understand every single type of output that sysdiagnose delivers, this can help you with that and help you find what kinds of files you need to solve whatever problem you're looking into. It might have occurred to you that the name is strange, Gary. Why? It's just a combination of the names of grep and YARA. So this is where I'd like to invite you, if you've got your computer on you and you're interested, give it a download and you can play along. There also are some game files in there. There's a list of questions that will be a little bit more engaging on an individual level, if you will play along, than the examples that I'll give here, which are more introductory. So yeah, if you'd like to, please go download it, and you'll find the game files in the repo. You can download the tool by going to the Releases tab and finding the installer there. And then once you've installed it, I'd encourage you to download. I mean, you could clone down the repo also, but you could download it as a zip and access the game files that way. And I'll keep the link to the repo at the top of all of the slides. So if at some point you are inspired to go and download it, there it is for you. Let's take a look at the tool itself now. This is the main view of the tool, and it's got a few different parts to it. So we'll just take a brief look at each of them before going into actually using it. So the first part is the file browser, which you're well familiar with, the idea of a file browser. So I'll just point out the interesting stuff, which is the carets to the side of the directories to show directory contents. There are information buttons next to some of the file names that you can click to show those descriptions that I was talking about for sysdiagnose output files. There are checkboxes so that you can select which files will be included in your search. Some less obvious pieces are that you can long press to quick view, and you can double click to open a file in its default app that it would use to open. All right, so that's the file browser. That's all you really need to know about that to begin with. Let's take a look at the right side part of the view that has to do with the searching and information about what you have selected, like in the selected files block. You can see that the number of files that you have selected at any given time are shown in this top part here. And the only other thing on this block is a details button. So let's check out what that does. It contains some options that you can have selected or deselected that involves being able to search file names, contents, sysdiagnose descriptions if it's a sysdiagnose output directory that you have open. And we also have a list at the bottom of files that are selected at any given time, so that if you have closed some of the directories, the subdirectories here that you had open, you can always figure out what is being searched that way. So that's the top block. Let's look at the middle block after I clear out the selected things. And this is the first of the search blocks. So this is the pared down version of grep that I mentioned. And if we click into the details block of this, or the details button of this block, we'll see the options that are most useful, in my experience, from using grep that I brought over to this tool. So it's not a huge man page like grep, like the grep options, but they're the most useful ones, I think. We've also got some examples, some simpler examples on the top, and then some slightly more nuanced examples on the bottom, nothing too crazy still. But then at the very bottom of this details part is a description of what you can expect in the result list of this type of search, which we will see shortly in action. So that's the middle block. The last block is the YARA block. And this one's not too different from the others. It just has a few buttons and a text area to put your rules. So let's check out what the details view of the YARA block contains. And it looks not that different than the other ones. It has a description of what it is and what the different elements of a YARA rule are, which you don't really need to know to use the tool, because there's this add rule button also that takes care of the syntax for you. But anyway, it's there. There are some examples. There's also a description of the resource that you would want to use to learn more about how to write more advanced rules. And there's also a description of what you can expect in the output result list. All right, so that's a little tour. Let's actually try using it. So we'll just start with the simplest kind of example. We'll use Quick Look to see the contents here, and it's probably pretty small, but we've got macOS in there. So let's just select that file and do the simplest kind of search. We'll search macOS, and doing the demo on my Intel machine, so it's a little slow, but it's very fast on ARM. And we see that we get the name of the file that matched, and we also see the line that matched. We also see the number of files that matched and the number of lines that matched, which can be useful sometimes. You can also search the result output and filter that, which can be useful when you have a lot of results going on. And then what we'll do is we'll just clear that, and we'll do a YARA rule for the same type of search, just the string macOS again. And you can see that the add rule button just added a valid syntax YARA rule that you just drop your string in, pretty much the same as the grep type search at this point. And for the results of this, you can see again, we've got the name of the file, and we've got the name of the rule that matched this time instead of the matching line. So that's the major difference. But you can also see the number of files that matched and the number of rules that matched there. So here's a table that I have also in the README of the repo that describes what different conditions you might have about what you need for your input or what you need for your output, and how those needs are best met through one type of search or the other. For example, if you need to see the matching line, you'll need to use grep. If you have a large file and performance is important to you there, YARA is a lot faster. So those are some examples, but if you need to know more, go and look at the table on the README in the repo. So time to actually use it beyond just the small example. Let's start really simple and just open the directory that we want to do our searching in. All right, easy enough. Another easy one. Let's find this file that we know we want to search in. So we'll just type that into the file browser search bar. There we go. And it'll show us what matches that string. And we can select that file. And then we will go on to do a little search in that file. We're going to need to have case sensitivity be important to us here. So we'll capitalize because we're not using the -i flag that you might be familiar with from grep. So make sure you use capital V and capital N in this case. And then we press search. And just like in the other example, you can see the name of the file that matched and all of the matching lines from that file, which that's great. So if we had wanted to know about what kinds of volumes were on the device at the time that this sysdiagnose, which is what we're looking in, what volumes the device was aware of at the time, this is how we would see that. Maybe we want to know not just the names, but how many were there. Maybe we have an expectation of the number of volumes that the device was aware of at that time. So we can use a flag there, -c to count, and we get the count. So maybe we want to know how many lines are in the file that describe each of the different volumes. So a way we could do that would be by looking at the line numbers and telling the difference between them. So let's try doing that. And we'll use the long version of this flag. Just type that out and search that. And you can see that we get the line numbers next to each of the matching lines. And from there, we can say, oh, this volume has a lot of information in the file about it, or not so much. All right, so we've done that simple search just to kind of get you into the idea of how to interact with it, basically. This one is just slightly more complicated in that we will first have to find a directory and then open it and select some sub-files. So not that much more complicated. First, we'll search for system profiler, open that, and then we want to know maybe about the software and hardware information about the device that the sysdiagnose was taken from. So we'll select those 3 files, and we'll do some searching in those files to see things that we care about, like maybe paths and versions, since it's software and hardware information. So first, we'll create a YARA rule, should be easy enough, with the add rule button, where we just drop our string in. And I'm actually going to also rename the rule so that when we see the rule name in the results list, it will match the strings that we entered into the rule. And we'll be able to get our information a little more easily. Before we press search on that, though, let's make two other ones, one for version and one for processor, since we're looking in hardware information. We'll see if that's in there. So I'll just do the same thing, rename the rule from the default random value, and put the string just between the double quotes. And it already has a condition there that says all of them, which will change that in one of the rules later. But that is good for any rule that you will need to make in the beginning here. Great. So then this rule for processor with the string in there. And once we search that, we'll see that all three files that we selected matched for some rules. We've got the two top files each had 2 rule matches, and the bottom one only had 1 match. OK, so we know now which files contain processor, version, or path information. We can make it a little more specific. Right now, we've got case sensitivity in the rules for our strings. So let's try removing the case sensitivity. We can do this just by putting the string no case after the end double quote in the rule. So we'll do that for the path rule and the processor rule. And then for the version rule, we'll change the condition, finally, for one of them. And we'll say, since the version string is pretty common, let's only match on files that have the string version more than 10 times. So we assigned the string version to the $A0 variable. And using the pound symbol here, we'll say, now count it, and if it's above 10, then the rule will still match. So we'll just select that and say pound A0, which is the label of the string, is greater than 10. And now we'll press search with those changes in place. And we see that now not all 3 files match anymore, because the bottom one had been matching on the version rule when it had any number of version strings in it. So now that the rule says only files that have more than 10 of that occurrence will match. So the results look a little different. Let's add another rule. This one will be a little bit more complicated in a different way. We'll put multiple strings in there. So let's see which of the files contain either macOS or MacBook. And any file that contains either one of these strings will match on this rule. And the way that I'm doing it here is just copying and pasting the first string, and then we need to enter our new string to match on, putting no case after it also. We also need to update the string identifier. So instead of $A0, I'm changing it to $A1. You can use any type of identifier, by the way. After the $, you can use words, or they can have numbers in them. I think it just cannot be only numbers. And then we'll update the condition there to be either one. And we will press search on that and see, oh, OK, interesting. We've got all 3 files matching again. They all have either macOS or MacBook. So we're getting progressively more complicated here. Let's look at some ESLogger output, which will be in the form of a big JSON file, which is, you can learn to look at it, but it's not very friendly at first. So we'll just take a look at first here to see what kinds of events we're dealing with in this big JSON file. And the way that we'll do this is by writing some YARA rules where we'll include the event names in one per YARA rule. And if you want to know more about ESLogger or endpoint security, a good place to start is the manual page for ESLogger. It's kind of fun to learn about. And the idea of it in general, for anyone who doesn't know, is that it's endpoint telemetry, but it's on the device there. So I have pasted in the rules that are associated with all of these event type names, and I made sure to escape the double quotes so that we match the event names instead of just other occurrences of these strings. And we can see that, OK, we've got something involving TCC, something involving BTM, and a bunch of exec events, I'm sure. They're very common. So, all right, BTM. Maybe let's look a little bit more into BTM. So we'll transfer from a YARA type search of the general contents of the files into a more specific search using grep to see which lines are matching on a given string. So we'll just search BTM in there, and there are a lot of letters in here now. So the way that we can filter this down a little bit is we can use the result search to be able to highlight things that we're more interested in. So maybe we want to know what paths are involved here, or maybe we know that BTM involves items, so we can highlight item, and we can see, OK, calculator, something to do with calculator. And then another thing related to item is login items. So there's something to do with calculator and login items going on in this line of JSON. And so that's how we can get a little bit of insight into this giant JSON file and drill down based on things that we know we want to know. So not Gary, but a different tool from 2 years ago that my boss, Jaron Bradley, and I wrote together is this tool, Sprite Tree, that I figured I'd mention since I'm up here talking about ESLogger output anyway. This is something that you can load in ESLogger JSON into, and you can see it in a process tree type format. So you can start to make sense of relationships of different events to each other based on its types of process IDs. So if that's something that you do in your world is look at process relationships, then I would recommend taking a look at this tool because it also can help you to make sense of ESLogger output in a way that is really hard if you're just looking at it as a list of JSON objects. Looks like it doesn't want me to go past if the video is not done. So this is a beta version of Gary, which if you're using it, maybe you can tell. But in the next version, I intend to do a couple of things, including fixing all of the bugs that I know about, of course. Also, I would like to use macOS 26's ability to leverage the local LLM to create sysdiagnose file descriptions instead of having them generated in static from when I package up the app and give it to you. So that'll be something that it could do dynamically and for all files included in that output. Another thing is to be able to select multiple files more easily with one click instead of having to do multiple clicks to select multiple files. Also, searching the descriptions more easily with one click is something that will be in the next version. And then also dragging and dropping files in from wherever else on your file system to be able to search files that are not already grouped on your system. So it'll be a little more transitory in that next version. And then beyond the next version, the immediate next version, I would like to bring in YARA X, which is the evolution of YARA that's faster and written in Rust, I believe, instead of C. And it has some more features that are not built in already to the original YARA. I also am really excited about the idea of being able to search binary symbol tables and shared library or binary shared libraries in a way where you can have multiple binaries selected at once. Anyone else, I guess, who's interested in binary symbol tables maybe would also be interested in that because it's kind of annoying to do in mass as it is. Also, searching timestamps is something that can be a challenge. So having a way to define all of the formats of timestamps that you will want to search for, and then entering the exact time that you want to find that would be in any of those formats, something that would be useful for searching groups of files. And I would love to know whether you have ideas also that would make your experience using the app more pleasant or would make you use it at all in the first place. So if you would bring any ideas to the repo, I'll make sure to have the discussion open on the repo or the issues. I'll make it clear in the README. And I would really love to know if you have any ideas about how you would want to use it. So thank you very much for listening. I hope that you can find a use for it or that it makes something that you already do easier for you. And yeah, this has been my pleasure. Thanks.